Summer 1941. German engineers scramble to counter Soviet tanks. Ferdinand Porsche gambles everything. He orders 100 cutting-edge chassis before his rival even tests theirs. The result is a 65-ton monster that terrified its own crews. How did pride and politics build a tank so advanced that Germany feared admitting it was a mistake? The real story begins with the Eastern Front's brutal shock. In the first months of Operation Barbarossa, German columns pressed deep into Soviet territory, expecting to outmatch every tank in their path. Then reports began to filter back from the front. Soviet T-34s and KV-1 tanks were halting entire panzer spearheads. German anti-tank guns bounced off thick, sloped armor. The T-34, with its wide tracks and powerful 76mm gun, could move through mud and snow where German vehicles bogged down. The KV heavy tanks, even slower, seemed almost immune to direct hits. Crews described shells ricocheting like pebbles, and commanders watched as their best weapons failed to stop these new Soviet machines. For the Wehrmacht's high command, the shock was immediate. Decades of German tank doctrine, built on speed, maneuver, and lighter armor, suddenly looked obsolete. The Eastern Front demanded a new answer. On May 26, 1941, the order went out to Germany's top designers: build a heavy tank, at least 45 tons, armed with an 88mm gun. The specification drew on the fearsome reputation of the 8.8-centimeter flak, already famous for destroying both aircraft and tanks in North Africa. Now that firepower had to be mounted on a mobile fortress, the urgency was unmistakable. Henschel and Porsche, the two engineering giants, were both tasked with bringing their visions to life. Porsche, known for his bold ideas and direct access to Hitler, saw a chance to leap ahead with radical technology. Henschel, with its reputation for reliability, took a more conventional path. But behind the scenes, the real driver was panic. The Red Army's armor had exposed the limits of German industry and doctrine in a single summer. Every delay risked giving the Soviets an even greater edge. Procurement officers scrambled to push contracts through. Krupp began cutting armor plate for new hulls. Siemens Schuckertwerke prepared to supply the electric motors and generators Porsche demanded. The clock was ticking, and the Eastern Front was unforgiving. There would be no second chance if the next German tank failed to meet the challenge. Ferdinand Porsche's vision for the new heavy tank went far beyond thicker armor and a bigger gun. Where Henschel relied on tried-and-true gearboxes and mechanical drives, Porsche set his hopes on a radical petrol-electric system. Under the engine deck, his design paired two Maybach petrol engines to a pair of massive Siemens Schuckert generators. These fed power to electric motors, one for each track. In theory, this eliminated the need for a conventional transmission, promising smoother acceleration and simpler control, just a lever for each track. No clutch, no gear shifting. The engineering teams at Nibelungenwerk and Siemens Schuckertwerk raced to assemble the first prototypes. The electrical system, though, demanded an enormous amount of copper, hundreds of kilograms per vehicle, at a time when German industry was already rationing every strand. Copper was not just a cost issue, it was a strategic bottleneck. Every meter of wire that went into a Porsche chassis was wire that could not go into aircraft, radio sets, or U-boats. On paper, the petrol-electric drive looked like the future. In practice, it was a maintenance nightmare. The generators and traction motors filled the hull with a maze of cables and control boxes. Heat built up quickly, especially under battlefield stress. Cooling fans and extra ducting added weight and complexity, but still could not keep temperatures in check for long. Dust, mud, and vibration took their toll on insulation and moving parts. When something failed, repairs required specialists and spare parts that were never in the right place at the right time. The decisive moment came on the 20th of April, 1942, during Hitler's birthday demonstration. Both Porsche's and Henschel's prototypes rolled out for inspection. Henschel's tank, with its straightforward mechanical transmission, ran reliably through the trial. Porsche's machine, by contrast, struggled with overheating and electrical faults. The verdict was clear: Henschel's design was chosen for mass production. Porsche's gamble on the petrol-electric drive had lost, but by then, the damage was done. Nearly 100 expensive hulls already filled the factory yards, bristling with copper and promise, but with nowhere to go. Rows of unfinished Porsche hulls filled the Nibelungenwerk factory floor through the autumn of 1942. Each weighed over 60 tons, armored and engineered for a tank that would never see service. Scrapping them was unthinkable. Instead, the order came down: transform these stranded giants into something the army could actually use. The result was the Panzerjäger Tiger P, soon known as the Ferdinand. Between March and May 1943, engineers rebuilt 91 of the unused chassis. Gone was the rotating turret. In its place rose a fixed armored casemate, bolted directly to the hull, housing the most formidable anti-tank weapon in German service, the 8.8-centimeter PaK 43-2L71. This gun could punch through the thickest Soviet armor at distances other vehicles could only dream of. Ferdinand's armor matched its firepower, 200 millimeters at its thickest, enough to shrug off nearly any shell on the battlefield. The final combat weight climbed to 65 tons, rivaling the heaviest tanks of the era. Inside, engineers kept the twin Maybach engines and the complex petrol-electric drive from Porsche's original vision. The electrical generators and traction motors remained, with all their copper wiring and maintenance demands. Above the engines, mechanics installed ventilation grills and extra cooling fans, hoping to keep the system running under stress. The crew compartment was cramped, packed with ammunition racks and electrical equipment. 6 men would operate the vehicle: a driver, a radio operator, a commander, a gunner, and 2 loaders. But one key element was missing. In the rush to field the new tank destroyer, no provision was made for a hull-mounted machine gun. The design's logic was clear: destroy enemy tanks at range and avoid close combat. Yet this left the Ferdinand dangerously exposed to infantry attacks once the fighting closed in. It was a sniper with no sidearm, a fortress with a blind spot at its own doorstep. By late spring 1943, the first Ferdinand stood ready for action, massive, powerful, and already carrying the seeds of their own vulnerability. Dawn on July 5, 1943. 91. Ferdinands rolled into the fields west of Kursk, their engines humming and their crews bracing for the unknown. The battalions of Schwer Panzerjäger Abteilung 653 advanced behind the front lines, tasked with punching holes through Soviet defenses. On paper, each vehicle was a fortress: 200 millimeters of armor up front, a gun that could destroy enemy tanks at nearly 2 miles. But as the attack began, the reality of the battlefield set in. The Soviet lines were a maze of trenches, anti-tank ditches, and minefields. The Ferdinands moved at a crawl, 30 kilometers per hour on open road, and half that speed in the churned-up mud and wheat fields. Every kilometer pushed the engines and electric drives closer to their limits. Within hours, the first losses had nothing to do with enemy fire. Mines detonated under the massive hulls, snapping track links and ripping into the delicate wiring beneath. When a mine shattered a generator or motor, the vehicle went dead where it stopped. Mechanical failures followed: overheated engines, burnt-out motors, electrical shorts from dust and vibration. Crews scrambled to restart systems, but the maze of cables and control boxes left even experienced mechanics helpless under fire. The radio crackled with calls for recovery vehicles, but towing a 65-ton Ferdinand under artillery bombardment was nearly impossible. Standard recovery tanks lacked the power to budge them. In many cases, the only option was to abandon the vehicle and retreat on foot. For the men inside, the armor that had promised safety became a trap. Immobilized Ferdinands drew enemy artillery and infantry like magnets. Soviet troops, quick to exploit a stranded giant, closed in with grenades and Molotov cocktails. Without a hull machine gun, the crew could only watch as attackers approached from blind spots. Survivors later described the fear of being sealed inside an electric coffin, knowing that a single mine or engine failure could turn the thick armor from shield to prison. Over the 12 days of the Kursk offensive, more than 3/4 of all Ferdinand losses came from mines, breakdowns, or abandonment, not from enemy tanks. Out of 45 vehicles committed by one battalion, only a handful remained operational by mid-July. The battlefield was littered with hulks, some burned out, others abandoned intact, silent testaments to a design that could not keep pace with the demands of war. Today, Technology still races ahead of logistics, and pride still shapes decisions in every field, from defense to industry. The elephant stands as a warning. Even the most advanced ideas can become liabilities when politics outrun reality. Ambition without restraint always leaves a cost. What do you think?